Now we deal with games with saddle point. Games with saddle point are those games which are played using the pure strategies. Pure strategies are those strategies which are played by the players continuously. That means they don't change the strategy from time to time. They keep on using the same strategy. So those kind of strategies are known as pure strategies. If the players keep on changing strategies, those strategies are known as mixed strategies. However, we'll take a problem and solve the game using the pure strategy games, or which are also known as games with saddle point. Solving the problems with games with saddle point is much easier compared to games without saddle point. So here there are two players known as player A and player B. In this problem, player A has 4 strategies A1, A2, A3 and A4, whereas player B has 5 strategies B1, B2, B3, B4 and B5. And in any game, there is no such necessity that player B and player A should have equal number of strategies. Player A may have certain number of strategies, player B may have certain number of strategies. That means player A may have 3 strategies, player B may have 4 strategies, or player B may have 4 strategies, player A may have 5 strategies. Likewise, there is no restriction as such. They need not be equal number of strategies. Here in this problem, player A have 4 strategies, player B have 5 strategies. The numbers which are displayed in the matrix or table are the gains to player A and losses to player B. To solve this problem, the first step what we need to do is you have to write down row minima. After writing down row minima, we have to write column maxima. Row minima is the least value in each row. That means the least value of player A strategies for each of those strategies. For player A, we have 4 strategies A1, A2, A3 and A4. Now we'll check player A's strategy A1, for which there are the values of 3, -1, 4, 6, 7, out of which -1 is the least value. Similarly, for player A, for A2 strategy also, -1 is the minimum value. For A3, 6 is the minimum value. And for A4, -4 is the minimum value. So we call them as row minima. That means the most minimum value in each row is written under row minima. Then we go to write down the maximum value in each column, which we call that as column maxima. Column maxima represents the maximum loss to player B for each of its strategies. So for B1, 16 was the loss, B2, 11 is the loss, for B3, 6 is the loss, for B4, 14 is the loss, for B5, 12 is the loss. Likewise, we find the maximum loss for each of the B strategies and minimum gain for each of the strategies of player A. Now, actually player A wants to choose a strategy which will give the maximum gain out of the minimum gain. So in the problem if we see, that is the reason the row minima is written. A wants to know what is the minimum gain that he can gain if player B chooses whatever the strategy he wishes, because B's strategies are never under control of player A. But player A has control over his strategies, whereas player B has control over his strategies. But player B will not have control over A strategies, and player B has no control over A strategies. That means when player A choosing any of his strategies, player B is free to choose any of his strategies. So these row minima represents the minimum gain that can be gained by player A for each of his strategies when B chooses his best strategy. So here now player A wants to maximize his minimum gain, and similarly player B wants to minimize his maximum loss. That is the reason column maxima is written. Column maxima is written to know what can be the maximum loss that can occur to player B when he chooses B1. Similarly, when he chooses B2, what is the maximum loss? That is 11 here. And similarly, when he chooses B3 strategy, what is the maximum loss? That is 6. Similarly, when player B chooses B4 strategy, what can be the maximum loss? So that is 14. Similarly, now player A also wants to check what is the maximum gain. So among all the 4 strategies under row minima, 6 is the maximum gain. So player wants to choose the strategy A3, which is given by 6, that is marked with box, which we call that as maximin. What maximin indicates is maximizing the minimum gain. Similarly, player B wants to choose a strategy which will minimize the loss, that is marked with a circle, which we call as minimax. That means minimizing the maximum loss. So we call that as minimax, minimizing the maximum loss. That is the reason we mark that. Now if we choose, if we extend or if we observe column maxima and this row minima, both of them will meet at point 6, because the same 6 is the maximin and the same 6 is minimax. Both of them meet at the same point or intersection of those rows and columns, which we call that as saddle point, and that will be marked with a circle inside the box, which we call that as saddle point, which is the solution of the game, or which is also known as value of the game. This is represented by a circle in box or square. So maximin is marked with the square box and minimax is marked with circle. Both of them meet at the same place, so we put the circle in the square box. That is the reason we will mark that, and that is the solution.